This tutorial will be the next part of the surface class of videos in which we're going to learn about conducting viewshed and visibility analyses. Viewsheds really break it down to these two questions. Right? If you have a series of points that we're going to call observer points here, based on some surface of elevation beneath them, what can they see? Right? What can be seen from these points? And then the inverse of that question would also work for everybody who's not here, not one of these 3 points. Where would you have to be able to see one of those points? Right, so, let me just rehash. There's 3 tools we're primarily going to use when we learn about these. Viewshed and observer points are going to be the ones we learn the meat and potatoes with, just because they came first and are the basis. And then there's visibility, which is probably what you'll end up using. It's a much more graphically logical and tool that's much more logical to use. It doesn't add any new functionality as much as it just makes it easier to use the existing functionality. So let's just start here so we know them all. All right, so it's going to need to know a couple things. Of course, it needs to know the surface of elevation. Then it's going to need to know, what are the observer features. Like I said, it'll also do a polyline, like a road, for example. But just be careful that if you put in a road, it's going to measure every vertice of that road, right? And it's going to be a big calculation, so it'll take a lot of time. So we'll call it viewshed 1. Last thing here, a very cool one's called the above ground level raster. Right? So if you imagine, it's going to look out and tell you every area that can be seen and can't be seen. So for all those cells that are in the can't be seen category, a new raster will come up and tell you how much higher those cells would have to be able to be seen, right? So it just kind of gives you that delta for your analysis. So we'll just do one called AGL. This allows you essentially to use corrections in your calculation to model the curvature of the Earth. We'll just do a basic one for now. Right, that's your above ground level. It's very similar to an elevation. It's just essentially telling you how much higher you'd have to be. But here's the meat and potatoes, right? And they have another one of those tools that tends to be a more logical symbology. Breaks it in as visible and not visible. And then if you go to the attribute table, it'll tell you a little bit more. These are all the cells that are not visible. 1 means visible by one of the places. 2 means visible by 2. It's a really tiny thing right here, because there's only 22 cells. So one thing that I'm sure a lot of people are now asking, or maybe they're being somewhat skeptical on, they're going, excellent tool, right? But this implies that the Earth is bare. And of course it does, right? For here, my elevation is only surface elevations. But it needs not be that, right? From a very practical and easy standpoint, if you have access to LiDAR, then you do have access to a digital surface model, right? Not just elevation, but one that takes into account the spot elevation, and it'll add to that buildings, it'll add to that trees, and any other layers that you have. So, right, if you have the technology, you can make it just a digital surface model, or digital surface model from LiDAR, and it's much easier to use. If you don't, right, and this is one of the things I'm hoping these videos continue to convey over time, even if you don't have the LiDAR technology, you kind of have the mental technology. Right? Imagine if you have a surface of elevations. And imagine from the same planning office you're able to find a layer of building files that are vectors. And lo and behold, those buildings have something about elevation within their attribute table. Well, you could use convert to raster, right? Use the elevation value as the raster value and then just add that to the elevation. And now you have an expanded surface, which is, building heights and elevation. Someone may have a land cover one that has trees and shrublands, or they may even have a point file for trees, and you could add that height as well. Right? So you can create a rough approximation based on other pieces of data that you have if you don't have LiDAR. For the purposes of this video, we're just doing the bare Earth elevation, but again, the surface that you put in to this doesn't have to be bare Earth. It doesn't have to be just elevation. It can be a true surface model that incorporates building heights and so on and so forth. So even with those building heights, let's say, right, we're trying to build these towers, right? These are going to be cell phone towers or towers of worship or whatever. Those towers are ultimately going to have a height, right? And that's not being taken into consideration in this first iteration. They're essentially just taking the elevation value right there, and I think adding 1 foot to it is the default, and that's what they're looking for. So again, if we wanted to make sure that each of these had a certain height, right? So now it's not simply what can I see, it's what can I see if I'm raised up 100 feet, and what areas can see me if my height is raised up 100. And you do that in the Viewshed or the Observer Points tool by creating a field called Offset A. Right? And until you get to the Visibility tool, and we'll explain how that's different. If you're working in Viewshed or Observer Points, it must be spelled like this. Right? Offset A. Make it, right, just 6. Go back to our trusty field calculator, and I'm going to enter the value 100. And we've now created something that is saying extrude each of these up 100 feet from whatever the base elevation is and recalculate the viewshed based on that. They don't have to be all the same. I could make one 50, one 200, whatever. Right? From a practical standpoint, imagine this is the height of the tower, right? The height of the observers. That's what we're modeling here. So the other steps remain the same. We'll go to Viewshed. All right, we'll drag in the fill, which is our elevation. Drag in our observer points. They now have something called Offset A that the tool is looking for when it runs these calculations. Don't need an AGL anymore. Let's run it. I'm going to take its time, maybe a little bit longer, because now it's adding an extra little element to the calculation. Right, and there we go. Right, I mean, we've definitely switched things up a little bit. I'm going to take my original Viewshed and I'm just going to give it the same kind of symbology here. I don't know if it's actually going to work because our values are different. There we go. Good. All right. So what were we originally? That's what we could see originally, right? I've got my original Viewshed on, but raising it by 100 feet, all new kinds of area open. Particularly, we see area open here in the area where 2 can be seen. Now there's a whole bunch of area in which 2 can be seen, and even some small area somewhere, there's like a valley, tiny valley somewhere where 3 can be seen. So these things, I'm going to jump real quick to a web page I have open. Right, if you go to ArcGIS Resources and you do a little research on Viewshed, Observer Points, and Visibility, it's going to talk to you about these things that are called controlling for the visibility analysis. Right, so there's a series of fields we're going to demonstrate. Offset, which we just did, Offset A, essentially what can I raise the tower up, and Offset B, right, it adds a distance to the surface for everywhere else. Right, so I like to think, imagine that is the height of the people who are looking up at the tower everywhere, or those people brought a ladder with them, or whatever. Azimuth, that's the compass bearing, right? So if you only want to search in a northeasterly direction, you can limit that, or if you only want to search in a south direction, you can limit that. Vertical angle, right? Vert 1 or Vert 2, that's essentially if you're tilting your head up or you're tilting your head down to be able to look at something. And radius, one that we will demonstrate, that's just do I want to start searching before a certain point or after a certain point, right? So radius 1, essentially the start distance, right? I'm only going to look for cells that are closer to X. And radius 2, maybe I'll take into consideration that your eyesight diminishes as it gets to a certain distance, or that there's fog after a mile or something. Right, so these are the base terms to be able to find. I'm going to run through a couple of them here just to save time in the video. Right, so the second one that I might bring up would be Offset B. Right, so Offset B is essentially saying, and that's for just for example purposes here. We're going to make it 6. We'll say that's how tall people are. For that one, we're just going to make it 10. Just for a quickie. So now, it's right because Viewshed and Observer Points, they independently run the Viewshed analysis for each point individually, and then they add them together to find an aggregate area of visibility. So the way Offset B is going to run, this area is going to look first. It knows that this tower is now 100 feet up, and it's going to presume that the elevation values everywhere else are increased by 6 to view that. So if you increase the elevation values by 6 everywhere and the tower by 100, who can see me? If you increase the elevation values of 6 everywhere and by 100, who can see this tower? And if you increase the elevations everywhere by 10 and this by 100, who can see that tower? Right, so that's Offset B. You know, a good metaphor to think about it is it's the height of the person who's standing trying to look at the tower, right? Because it's going to raise every other cell it's not an observer, or sorry, an observation point up. A sillier way to look at it is, maybe you're a 6-foot person with a 4-foot ladder here, right? Or it's a pedestal you're carrying with you that you're going to put down at any point to allow you to see a certain height. So I'll set you back to 6. See if it makes any difference here. We'll run the calculations the same. We'll go to Viewshed. I'm going to drag in the fill. I got my points that are now taking two things into consideration, right, with offset A and B. Offset A, they're taking into consideration the height of the towers, the height of the observer points. Offset B, right, they're imagining they are X feet tall, right? They're adding a certain value to every single cell that wants to view these three, or be viewed by those three, depending on how you look at it. To offset B, we don't need an AGL. We'll run it. I'm not sure if it made too much of a difference, but it did make a little bit, right? We can see that having that extra 6 feet did provide a couple of fill-in gap areas where they would be able to see. All right. So now let's do radius 2 as the kind of final one, and other ones, I encourage you again, take a look at azimuth 1, azimuth 2, vert 1, vert 2, radius 2. If you want to add some additional analysis based on, the angle you're craning your neck to look at the visibility, or if you want to look in a north and northeast direction. And I'm just going to show these three so we can keep the video at a reasonable time. Oh, we haven't even put anything in yet. I got ahead of myself. All right. So now I'll add radius 2, just because it's usually an easy one to understand. All right, radius 2, maybe you can call it the horizon, quote unquote, or you can call it the fog, right? Or you can call it your, grandfather's eyesight. Whatever you want, it's just essentially what's putting the outer limit on how far we should look. All right, so just to make this easy, maybe we'll do 30,000 feet, or let's do 35,000 feet, right? Interesting thing to keep in mind about this, right? It's going to take on the projected coordinate system, or whatever you project it in. So, if I were in meters, this would be meters, but I know I'm in feet, so I'm going to enter a value in feet. So this is going to presume that it's going to stop looking for visibility at a distance of 35,000 feet. Okay, so that's the big distance. Towers are going to be 100 feet raised. Imagine that any place we're looking or being observed that aren't the 3 towers, we raise ourselves up by 6. And the observation is going to cease after 35,000 feet. So we'll run to Viewshed. Whoop. Mixing them up by accident. So there's the fill. There's our observers. We'll do radius 2. I think I put radius 2 in that. Let's just make sure. Radius 2. And we'll run it. As you can kind of see it out of the corner here, the big change, right? That whole area up there disappeared, right? Not because it doesn't have good elevation to be viewed by here, but because now we're starting to factor in distance. Maybe there really is like a layer of fog, or the horizon is built in such a way right now, based on, with the kind of like the haziness that's coming in, or your own eyesight, or any number of factors, that you're really not going to be able to see much after a certain distance, right? You'll be able to see that. Again, we have the things recorded in the same way. What can be seen by 2, what can be seen by 1. So let's take this same one here, and we're going to subject it to observer points. All right, so we've used Viewshed essentially to answer the very simple question, what can be seen and what can I see? Observer points is going to do it a little bit more complicated. It's going to say for each of the X number of observer points, 3, what are the number of unique combinations, right? What are the cells that only 0 can see? What are the cells that only 1 can see? What are the cells that nobody can see? What are the cells that 0 and 2 can see? What are the cells that 1 and 2, right? So it starts to break it down into an observer by observer basis of who can see what. Now we'll take a moment and actually look at the attribute table that's created, because it takes a moment. It's a weird one that comes back. All right, so we got the same conditions going on here, that we're limiting it by 35,000 feet. All right, a series of values come back. Be careful right? Because the initial thing you want to say is, aha, pink means 4 people can view it. But we only have 3 observer points. So how would that even be possible? Right, so let's open up observer points and seriously take a check of what's going on here. The values don't tend to be super important to find out. Really, they just stand in for these fields here. These fields are saying observer point 1, right, and it moves, I think, with the FID of the vector, right? So observer point 1 would be here, observer point 2 would be there, observer point 3 would be here. That's how it's moving. These are the areas where none can be seen, right? No 3 can see any of those areas. Observer point 1 is positive, so observer point 1 can see all of these cells. Value 2 stands in for observer point 2 can see all of these cells. Value 3 stands in for observer points 1 and 2 can see all of these cells. And finally, value 4 stands in for only observer point 3 can see these. Right? Since we limited that viewshed analysis, there seem to be no areas where 1s and 2s can see this area and 2s can see this area, 3s can see this area. Right? So again, the value is meaningless. Look from the value here. Value 1 represents that these are the areas observer point 1 can see and be seen from. These are the values that observer point 2. Right? 3 might make you think it's going to be observer point 3, but it's not. It's saying these are the values that observer points 1 and 2 can see and be seen from. These are the values that observer point 3 can see and be seen from. So that's the use of observer point, to really identify the exact mix of who can see what, in case that's important to your analysis. Right, so visibility, here's how visibility is the superior tool. Right, you drag in fill, we're not going to run it, we're just going to show it. You drag in fill, drag in your random observations, right, and here's where it's real important. Very nice. You actually can pick, do I want to do frequency, which is essentially like a viewshed, or do I want to see observers, right? It's going to identify the exact observer for each point, right? So this one mimics viewshed, this one mimics observer points. Other thing that's very, very neat here, look at that. You don't have to rely as much on remembering offset A or offset B or all of this jazz, right? For surface offset, you could put cheese factory, right? You know, for observer offset, you could put, you know, West Coast video. I'm just using random weird ones here because I want you to understand offset A, B, and radius are going to matter for viewshed, and they're going to matter for observer points. But in visibility, you're just going to link something up with whatever is storing that value in the field, right? So it just gives you a little bit more control. Didn't like that because that's already an A. It just gives you a little bit more control over how you choose these values.